In this test, I'm going to determine the effectiveness of a tandem LDR switch system that will operate or activate this auger when necessary. Basically, the way this will work is, what I have here are two LDR circuits. Basically, this is a photoelectric cell which turns a fog light on or off. I have one located here and one just on the other side of it there. And basically what we have here is a 20-watt light bulb that is shining a beam of light through a sight glass in the end of this auger that is keeping this LDR in off mode. This LDR here, we'll call this LDR number 1, is connected to this light bulb. Okay, and what's going to happen is charcoal is going to fill up in this column to a point where it obstructs the light beam, activating the LDR, which will in turn turn this bulb on. Now when this bulb is on, this LDR number 2, is off. And the reason that's important is because anytime this LDR number 1 can see light, we know that we are low on fuel. So we want this auger to be running. I have the auger switched off right now. This is the triac that controls the auger speed. As of now, it is not activated because it is in on mode. But just as a quick demonstration, I'm going to take this brush and obstruct the light beam to the LDR. And now that the carbon has obstructed the light beam, that light is on. When that light is on, the light beam activates LDR number 2 and turns off the auger. So the way this is set up is that when that light goes out, the switch is activated and power goes to this triac, as you can see here. And this triac is connected to this DC transformer. Now this is way bigger than what you would actually need. I just have this from other projects. This is a 18 volt transformer, I think. 18.9 volts. It's rated at 150 amps, but you could do far more than that, I bet. It has no harmonic distortion protection. I'm just alligator clipped to this. I have to check the polarity. You want it to be in reverse for the auger bit to function properly. So in this test, two things will be examined. First off will be the output rate. And second, we want this thing to shut itself off. Once it shuts itself off, I'm going to remove this cup. The device should then reactivate. I'm going to put the cup back in at that point and get it to shut itself off again. That is the only 2 cycles I'm going to do because I do not want to have to refill this hopper. It's not exactly the fastest thing in the world to do. This drive mechanism, by the way, is just sitting on there for quick removal. Because as I say, for right now, that's the only way I have access to the hopper. This thing is completely sealed off with a gasket, so it will not allow any gas to escape. So enough of that. That has nothing to do with this test. Let's get on with it. Okay, so here we go. Really nervous about this. I am going to flip the switch. There's the auger. It is going in the right direction. It is issuing fuel, and something just happened. Oh, I think some dust blocked out the light momentarily. Uh-oh. My chuck came loose. Okay, now in that first little initial test there, we witnessed 2 failure modes, actually 3. The first one being, I'm just going to have to find a cotter key for this. Second thing that happened was my chuck came loose. Now the only reason why I didn't take this off and weld it's because I don't have the tools to do that. I also noticed the switch was activating. The dust may have been blocking the light source enough to cause that to happen. We're going to test it again, and hopefully this run will go a little better. So here goes. Okay, fuel is coming out at a really nice level there. Okay, something just happened. Yeah, dust clouds are clogging my light source up. I don't like that at all. Oh, shit. Okay, got to shut it down again, unfortunately. I'm just going to have to get me a cotter key here. This isn't working out too well. Other than that, the switching mechanism seems to be working. Take 3. I have salvaged the welding rod for a cotter. I've anchored that down. And we're going to try this again. Seems to be turning the right way. Uh-oh. Early activation. So it's just getting so dusty in there that the light beam is indicating nighttime. So it's not working perfectly, but it's working. And it may function as intended. Watch this bad boy a second. Really grinding her up in there. This particular feed rate should be compatible with the combustion in the device. I don't see it burning fuel this fast, but I could be wrong. I can speed this auger up. I'm afraid to do that. It's actually a beautiful thing. I'm going to get a full 150 milliliters this time without a breakdown. Okay. Here in a little bit, the thing should shut off for good, indicating that the fuel level has reached this point just above the light, just above the glass eye, or whatever you want to call it, the viewport. Okay, and there it is. The device has sensed that it is full and has shut down because this light beam is obstructed now. This obstructed light beam has caused this RDL to activate this light bulb. This light bulb has caused this RDL to turn off. which is connected to our auger. And I am going to bed, finally. This thing's driving me nuts. I'll go to bed only if it turns back on when I drain this cup. Damn it! Alright, apparently we're going to need some vibration. It has clogged itself up. That is not good. Alright. Let's just hope the damn thing works when it has the blower on it and vibrating and all that. I'm going to bed anyway, I lied. It kinda worked. You just had to beat on it.